going to look at a couple of different ones in this series for fractions. This is really looking at section 2.7. We're going to look at a few techniques in terms of how do you solve an equation that has an x in the denominator, or we have a lot of fractions to deal with. The first real solution method is I really don't like fractions, and so let's talk about how to get rid of the fractions, period, and solve the equation that way. So that's what you're looking at on the screen right now. This is a method that technically is always a possibility, but sometimes it doesn't lend itself to be very easy. So when you have a situation like this, you've got x or 3 over x, and you have 4. So those are my three terms. The instructions here simply say to solve for x. If I don't do this, that means I'm going to have to maybe combine like terms or find a common denominator. One of the ways that we can do that is simply get rid of the fraction completely, or we call that clearing the fraction. I look at my denominators, right? I specifically want to get rid of this x in the denominator, so what I can do is I can look at all the different denominators that I have. Now, this one's really straightforward because I have a 1, I have a 1, and I have an x. So what I want to do is simply take this, this denominator, which we have x only right here, and I want to multiply. If I had an LCD, then I would have to find out, well, what would be the least common denominator, or maybe we have to find a mixture of denominators, and we can look at a different those things a little bit later. But we're going to take this one and we're going to multiply every part by that denominator. In this case, it's going to be x. So you can see here we want x times the right side and the left side. My results, x times x gives me x squared. X times 3 over x, well, the x's cancel. It would have been 3x over x, and the x's would have canceled out and left me with just positive 3. On the other side is easy, it's just 4x. And at this point, it becomes a traditional quadratic style equation. And so you can basically subtract 4 from both sides, add your 3, as it was in the original problem, and I can factor. In this case, it was very easy to factor, so I just went ahead straightforward, and I factored the problem. If I couldn't factor, I'm probably going to go directly to the quadratic formula and not really waste my time trying other methods that may or may not work. And so this is called clearing fractions. Look for this when you have some simple fractions that I can multiply, even if you have different denominators, that I can multiply so that each of the denominators cancel and I get rid of all my fractions, and then I solve it just like a traditional quadratic equation. This tutorial is going to cover a little more about rational equations. We're going to specifically deal with how to look at extraneous solutions, and we're going to take a part one where we have a fairly large fraction or rational expression, and we're going to try and solve it. So here's what we have to look at. We have 2x over x minus 1 plus 1 over x minus 3 equals 2 over x squared minus 4x plus 3. What we have to determine is how am I going to get this equation in a place where I can solve it, where I'm used to working on it. The first thing would be nice is if we had a common denominator, and then we could either get rid of the fraction or figure a way out where that we could work with the fractions despite having a number of complicated expressions in the denominators. So it would be great. What we're going to look at here is trying to find a common denominator so that I can get the fractions not necessarily equal to one another, but we can have the denominators equal. Once I get the denominators equal, in a fraction, if you have two fractions equal to one another, that means and the denominators are exactly the same, that means my numerators must also be exactly the same. So we can just basically set the numerators equal to one another, and this is how we're going to get to that spot. So the first thing is we look at both sides. We have an x minus 1 here, an x minus 3 here. I would really like to know what this is in terms of its factors. So I'm going to try to factor that. If it happens to be these two pieces or even similar to those, then I've got a really good start. So if we factor it, this is what we see. The left side stays exactly the same, but we factored the denominator on this side to show us exactly what the factors were. And it happens to be that they're exactly the same as the other two. So what I want to do is take one of each of my factors, and I want to make sure that every fraction has those as its denominator. The right-hand side of my equation is already got both factors. This side, I'm going to have to multiply the first fraction by x minus 3 on top and bottom, and the second fraction I'm going to have to multiply by x minus 1 on top and on bottom as well. And so we go through that. I take that very carefully, and I'm kind of showing you a piece at a time. I take this, I multiply both fractions. What this does is this allows me to have the exact same denominator in all three fractions. Once I've got that set up, then I can simplify the left side. Now that we have common denominators, I can go ahead and add the two numerators together over one common denominator, and I'll have a fraction equal to another fraction. If we go ahead and multiply through, this is what you see. So I went ahead and distributed the 2x to the x minus 3. Notice I didn't change the denominator at all. I left it in its factored form. There's no point in me kind of trying to multiply that back together. So we went ahead and distributed here. It got 2x squared minus 6x. This part was really easy. It was just x minus 1 times 1, so that didn't really change. And of course the right side didn't change either. I went ahead and put them in the right order so that they're all the same. Now I'm going to go ahead. At this point we have two fractions that have the same denominator. I'm going to rewrite these two fractions as one combined fraction. The only thing I have to really do here is just combine their numerators together, and it looks like this. So you have 2x squared minus 6x plus x and minus 1. So when you combine that, the 6x, negative 6x, and the x combine to give me negative 5x. Now here's what I was talking about earlier. When you have two fractions equal to one another, then I know that their numerators and their denominators equally, they're both going to be equal to one another. In other words, if this is the same on top on the bottoms, then my numerators must also be the same. It's the same thing like if you had 2x over 4 and 1 over 2, then when you simplify, you know that both sides are going to have to be 1/2. Or both fractions are and both have to be equal to 1/2. So what we do to simplify this is if I can get the denominators to be the same thing by finding that common denominator, at the end I'm going to take my numerator and I'm just going to set them equal to one another. And this allows me to come up with a traditional quadratic equation, and that way I can solve that by just factoring or maybe by the quadratic formula. And so you see here we ended it with negative 1/2 and x equals 3. Okay, now when you get done with a fraction, I don't care what the fraction looked like. If you had a rational expression, in other words, you've had x in the denominator, you are required to check your answers. All right, in this case, we have negative 1/2 and 3. If you were real quick and you thought about this, well, if I go back to my original problem, what are my domain restrictions? Well, domain can't be 1 and it can't be positive 3. So this is a big problem. Okay, if I plug in one of my answers, i.e. 3, I'm going to have a problem. So let's take a look at that one. So here's what we have here. We have 2x over x minus 1 and 1 over x minus 3, and of course we have the same denominators on this side. If I plug in my 1/2, not a big deal. It's going to give me numbers and they work out and it turns out to be true. But immediately I look at this, I can't plug in like this. If we get 0 in the denominator at any stage, at any point, on any fraction, it means that that answer can't actually be an answer. That is what we call extraneous solutions. It means it's not actually a solution. And so really what that is, that is a big, let me put this over this, that's a big no. Okay, so x minus 3 is not one of my solutions, right? Because my domain says, well, x can't be 1 and it can't be 3. So when I get x equal to be 3 here, this is exactly what we mean by extraneous. It's an extra solution that appears to be, by first glance, it looks like it's a real solution. Be careful about these. Always check your answers when you have fractions. We're going to look at one more example from chapter 2, section 7. This one's where we're actually going to have no solution. I just wanted to cover this example so that you won't freak out if you see something and you're like, wait a minute, how can all of my answers be wrong? So we're going to do the same kind of example where we have a fraction equal to a fraction or several fractions. This will be a good one to kind of go through the whole process again with you. This one's all equal to 0. This is very similar to the one we did prior to this. It's just instead of having two fractions on one side and one fraction on the other side, we've now just got all of the fractions on one side. So it really is no different. What we're going to do first is the same thing we did last time. We're going to look at all the denominators and try to determine what would be the common denominator with all of these, all of the factors that we can find. And you can see really clearly that this has a factor of x, this is a factor of x plus 2, and it's real obvious that if I were to factor this one, then it would have actually both factors at the same time. So that's really clear that we need to make sure that this denominator is what we're going to call our common denominator. And if I go ahead and multiply that through, I figure out what factor is not available or not there for your other two fractions. In this case, I need an x plus 2. And for this one, I need to have an x. I went ahead and multiplied this, or sorry, factored this one so that we could see it here. I really want my denominators to be very similar in the way that they look. So when you break this apart, you get this picture. I want to multiply this first fraction by x plus 2, so we do that top and bottom. The second fraction, we're going to multiply by x over x, and that way when I multiply these two pieces and these two pieces, I'm going to get exactly the same denominator all the way across my fractions, and it would look like this. And so once we've got that completed, we have basically we've set it up now that we can actually combine the numerators into one fraction. And so we're going to get one fraction equals 0. Because my denominators are all the same, that's basically when you add fractions or subtract fractions, the goal is to get all of the denominators to be exactly the same. In this case, it really doesn't matter what the denominator is, just so long as it's the same. Once I get it to be the same, then I can simply add my numerators together over that one common denominator. So we pull that back, and this is what it simplifies. It simplifies greatly to the equation you see here. X squared really doesn't have any like terms. We have an x, we have a 3x. Since it's plus, I don't have to worry about my sign changes. So 3x and negative x would give me 2x. Plus 6 and minus 6, since that's positive 6 here and negative 6 here, that gives me 0. So that's why you don't see a constant written there. Something to note that's really important here is that when you have this, and some people say, oh, now you're going to cross and multiply and solve for all those. True, you can. But the idea is even easier than that. What we have to remember that is when I have a fraction that's equal to 0, this entire expression is equal to 0. The only way that that is possible is when the top, my numerator, is actually exactly 0. The denominator can't be 0. If it's 0, then I have a big problem. Okay? And so when you have this equal to 0, then we have an issue. And if you're quick and you notice, isn't that the same thing? Isn't that x squared plus 2x on the bottom as well? If I go ahead and multiply through, that's x squared and 2x. So if I had the same thing on top and bottom, that's actually equal to 1. So when this is saying it's equal to 0, that's like saying 1 is equal to 0. That should cause a bit of a problem for you. If it doesn't, then you need to come see me because we have an issue. So when I go to solve this one, what I have to remember is that I can just take the numerator. Now, it doesn't always work out to be like what we looked at earlier where it's 1, but let's suppose that we don't realize that. I take my numerator, I'm going to set it equal to 0. What that does is it eliminates my fraction and allows me to work as if there is no fraction. And so what we have is we can set this equal to 0, factor, and then once we get done, we have x equals 0 from this value, and then x equals negative 2. If I weren't very careful, if I were not cautious, and I didn't listen to the teacher very much, then I would be done, and I would say, look, I did all this work and I got the right answers. However, as I said last time, you must always check your answers when you come to the end of a rational problem. So if we go back up to the top, and we're talking about domain restrictions, right? We know that this times this is going to be equal to that. So whatever the domain is for these two, it's going to be the same for the last fraction. That means I can't plug 0 in. If I plug 0, I'm going to get x minus 3 would be negative 3 over 0. Not possible. If I plug in negative 2 in this problem, it's going to make this part go to 0. It doesn't matter where or which fraction becomes 0 in the denominator. If it happens at all, it's no solution, or that particular answer is extraneous. In this case, 0 and negative 2 happen to be both extraneous. And so in this particular example, you're going to get an expression that does not have an x value at 0 or negative 2 because we have vertical asymptotes which occur at 0 for this one, and this one has one at negative 2. The last one has 2 asymptotes, okay, both vertical, and both of them occurring at 0 and negative 2. So you've got all kinds of problems with this one, right? Because my answers both are extraneous, my final answer is actually no solution at all. Okay, be careful, watch for these things when you get zeros, and so just to kind of put that in the problem, so no solution. Remember to check your solutions when you get down to the end. If you need to print this out to put it in your notes, that might be a good idea. So be careful with rational expressions. We did 3 of them. I want you to make sure that you are trying to figure out how to put common denominators or are clearing fractions, and you're checking your answers as you go back and plug them in. This stuff can be tricky, but if you're careful and organized, it will follow through.